Hello and welcome everyone to the panel discussion on delivering high performance systems. I'm Archana Ramesh from Aspire Systems and I will be your host for today's session. Today we will be discussing about key considerations and various other attributes in developing such systems. The webinar is conducted by Aspire Systems and it's a services company with working over 100 plus ISVs and enterprises across the globe, providing software development and IT services. Our center of excellence are SaaS, mobility, and business intelligence. The speakers of this session are Ruziru Gunasena, VP of Software Engineering and Architecture from IP Solutions, Shaikh Basha, Manager Architecture and Strategy from IP Solutions, Jyoti Rangarajan, Senior Technical Architect from Aspire Systems, and Sabarina Naganathan, Technical Architect from Aspire Systems. And Valan, Delivery Manager from Aspire Systems, will be the moderator. Kindly use the GoToMeeting chat window to ask your questions during the webinar. So now I will have Valan take over.
Yeah, thanks Archana. Hello everyone, and we are happy to have here for this webinar on the delivering high performance application. So to start with this panel discussion, the main reason or objective for developing a high performance application is to increase the business value. So some of the business drivers, okay, we see in the market today is to have a good user experience where the user feel happy when his screen comes up in a milliseconds, and also that drives the users satisfaction and loyalty towards the application and the organization. Also, it directly impacts the business value of any organization. So it also increases the revenue for the organization. So I would like to have Mr. Ruziru Gunasena, Vice President of IP Technologies, to share his view on the business value of delivering high performance application. Okay, I think Mr. Ruziru has got disconnected, I think.
Can you hear me now?
Yeah.
Yes. Now we can hear you.
Okay. Sorry, I think I was on mute.
Yeah. So
let me start over then. Quick intro of myself. I'm the VP of Software Engineering and Architecture at iPay. iPay is a division of Jack Henry. Jack Henry is a company which builds financial technology solutions for inside and outside the bank and credit union in US. So when it comes to financial technology, the availability and the performance is very critical. When you look at financial technology and the transactions, the customers and the industry is very demanding. So high availability and the performance of systems becomes very, very critical. So this is very near and dear to our hearts. So we look at the performance and the scalability as a very critical thing. I do have over 10 years of industry experience in financial technology, healthcare, and transportation. Also used to work for UPS before I joined Jack Henry, and being a transportation company, there also the criticality of the performance and availability was very important. UPS being a courier company and an airline as well. So again, systems performance and availability was very critical. Just to give a very high level business value, for any business, whether it's in the financial domain or the transportation or healthcare or any other domain, today our customers are demanding 24/7 access to their information. and also they perform transactions today 24/7 and round the clock, 365. So whether it's through their desktop or laptop or a mobile device on the go, the systems have to be up and running, and they are also now demanding the quick response from any system they interact with. They don't sit and wait for even seconds today for a system to respond. Again, the performance and the availability is important because of the customers are demanding it, and the lifestyle today is changing. Then the scale and also cost savings, which comes with these high availability and the performance systems, is very important today for the business. Again, in summary of business value, I want to say the main reason Aspire want to bring that to the partners and the clients to get their attention on this and what business value they can bring to the table in that is because of those reasons. So let me stop there and hand it back over to Waylon and see where he wants to go from there.
Yeah, thanks, Rusiru, for your good introduction on the business value of high performance application. And now we can have Jyoti, the technical architect, to speak on the scalability and the performance. Suppose in today's world, okay, the common talk is the performance is more related to the end user experience, and scalability is related to the business needs of any corporate. So can Jyoti clearly can mention, okay, what is the difference of the performance and the scalability?
Sure, Waylon. So if we have to define what scalability is, right? So scalability is the ability of a system to handle growing workload or a growing amount of workload. So what exactly do we mean by workload? It could be either increased user concurrency, could be volume of transactions that's getting increased, work processing that is getting increased. So let's say for an application today it's supporting 10,000 users, and later on if it has to start supporting let's say 20,000 or 30,000, the application should be capable to offer the same performance and also cater to that many user volume. So this is what scalability is, and scalability and performance goes hand in hand. Performance is usually the responsiveness of a system, or how much time does it take to load a page, how much time does it take to finish a work getting processed. So that is usually performance. Now with respect to performance is either measured with a single user scenario or with a concurrent user scenario. When you're talking about a concurrent user scenario, that's where the scaling itself becomes necessary, because under production, when so many concurrent users are accessing the system and so many workloads are getting processed concurrently, then what is the performance that we expect? So both of these together define the actual performance of any system.
Thanks, Jyoti, for your response on this. And maybe in today's world, if you see, we develop IT applications cutting across the different functional domains, industries, and geographical regions. So when we are speaking about the different categories of the applications we develop, so not all the applications need this kind of high scalability. May I invite Sheikh, the senior architect from iPay, to share his thoughts on what are the typical applications that need scalability in today's world. Sheikh?
Sure. Hi guys, this is Sheikh Basha with Jack Henry. I know Rusiru gave a good introduction of what we do from iPay Technologies and what the business value for having high performance and scalability is, and so did Jyoti talk about what they are. So we understand it's performance and performance and scalability is important, but what kind of applications really need it, right? Is it something like running on a desktop, someone like using one user, two user, do they really consider scalability and performance? Not really. So we need to talk about what are the different kinds of applications that that need the scalability and the performance improvements. So I put together, like, I thought 3 or 4 line items that I thought would be good to talk about when it comes to scalability and performance of applications. One thing that came to mind, the first one is the multi-tenant applications. So it's a software as a service multi-tenant application. What is a multi-tenant application, right? Back in the days when I used to work on mainframe, I know I'm dating myself, but when I used to work on the mainframe, there used to be a main server which has all the intelligence and applications built into it. And everyone who logs in will have a dumb terminal that connects to all these, the main server, and they have different sessions on the mainframe. So as time progressed, it changed into application service provider, and then it came into a multi-tenant software as a service application. So why is it important for a multi-tenant application to be scalable, right? The main reason is as more users log in, it's important that we consider how many users are, is this application going to be scalable at the design time. So we cannot add as we go through. It's important for a multi-tenant application to consider how many users are going to use, so we incorporate that in the design of the users, right? So that's one. The second is the growing enterprise applications, right? Any application that we use as across the enterprise. That's the second category that I could think of. If you think about like any healthcare applications that we have, and with the mainly in the US with the healthcare mandate, there will be an explosion of users that come into the system. So that we need to consider of what is the scalability that's going to look like in future. That's the second one. The third category I thought was about the applications that need periodic bursts, right? I mean, if you think about applications, each one of them across in the domain and across web, there will be spikes of user interaction and user using the system. One, you can think about any travel site, like if you think about anything that comes up across an assessment application, tying back the business value with this, what came to my mind was I used to work at UPS too, and I could think of an application where the air hub or the airport system used to use, where we used to sort the packages and load it into the airplane, right? That needs high performance and high availability and a lot of spikes in usage when it's going through the night sort, which is from 3 a.m. to 5 a.m. So it's very important for it to perform at its peak and at a high level, because any delay in the plane being loaded, any delay in the packages being sorted and loaded into the plane would have an effect in the flight taking off, which in turn would actually put penalties on the UPS airplane from FAA saying this flight has been delayed and it's missed the slot to take off. So that's another, like, that's the important thing to consider when we actually design a system for like transportation systems or any systems that need spikes in the during the peak hours of its usage. Then the other one is the Web 2.0 sites, right? I mean, if you think about social networking sites, the huge explosion in social networking, we need to consider performance and how we can scale, because you never know whether that social networking site is going to be used like today, like 1,000 users, tomorrow it could be many, many thousands. That's another important thing you need to consider. The other, the last two I think I have is the consumer-based internet applications. These are regular applications that we think of, like iPay Technologies banking application is one that we come across, and any e-commerce applications. Then comes, these are all like user interaction applications. We need to also consider like what are the big data analysis applications, right? So if you think about all the rules, business rules or data churning, data processing that we need to do, we need to consider performance there too, because it's important to spit out reports or any kind of a batch processing that we do in a timely manner, right? One thing that comes to mind, in my experience, is the census reports. It's the hospital medical census reports that I worked on, which was very time critical. These reports used to go out to the nurses in the hospital to say whether this patient is admitted, discharged, transferred, and based on that, they used to make their planning of the next stage for that patient. So it had many, many data analysis and data points that it has to go through. So we need to also not consider just the user experience. We need to also consider the criticality when it comes to the rules and the data analysis and the data batch processing that we need to do. So these are all the list of applications that I could think of that could be scalable. I think next Jyoti and Velan, they're going to talk about, so what do we do? These are the list of applications. What do we do to take care of and make sure we plan the scalability and performance right? So Velan, back to you.
Yeah, thanks, Sheikh. Thanks for your detailed explanation on the different kinds of applications we have in this world. As Sheikh was telling, okay, every business has their own need a different scalability approach, like some of the applications like online data processing, which has a very critical lifetime for a data, to the batch processing application, which can take even 5 to 6 hours to process. So I request Jyoti to explain what are the different approaches to achieve scalability, and in which scenario what kind of scalability to be implemented. Jyoti, to you.
Sure, Velan. So when you talk about scalability, right, so you can take either a scale up approach or a scale out approach. So a scale up approach is you add more resources to an existing box and then make the software perform better. Like very simple, assume you are on a 4 GB RAM or 8 GB RAM with a dual core processor. So what you need is more resource to process more workload. So what you end up doing is to add these resources, say make it 8 GB or make it quad core, right? So this is scaling up. So you as you can see, you have a single box and you make it fatter and fatter, right? The scale out is where you add more nodes to your processing and make the workload get processed better. This is how if you normally look at cloud and automated elasticity and so on, this is the concept, right? Add or bring in more nodes to the work processing unit and make the work get processed more quicker, right? So where do we go for scale up? Scale up is the first option mostly people take, right? Because it's very easy to achieve. You don't have to write a lot of code, or you don't have to do a lot of things in your application to be able to do that. Now, any which way, an application beyond a certain point will definitely hit the rooftop, and you cannot just keep on adding resources. And that is where you need to look at scaling out. Be it your web layer or an application layer or your database layer, add more boxes to it, add a more web layer by load balancing, add a more application layer by load balancing, do a database scale out, and then hence have the capability in your software to process more load. So these are the two broad approaches one can take to scale. Over to you, Venus.
Yeah, thanks, Jyoti. So as you are mentioning, today we have the advent of social networking sites where we talk a big volume of data, that to the unstructured data. So is it time that, okay, we have to say bye to RDBMS and start using this NoSQL databases? And what are your thoughts about this, Jyoti?
Yeah. So definitely this is one of the primary questions any application has before it starts, right? Whether to go for SQL or NoSQL. As you know, NoSQL is a non-relational database. Unlike your relation databases like SQL or Oracle, here the unstructured data is stored either as a key value or as a big table or as a graphical manner. The point is there is no one size fits all, right? So not every application can in fact go for NoSQL also. So what are the aspects of going for NoSQL? If your data is going to be more unstructured, it does not have more relations, you don't have to search your data more by the references, and there is not too much of reporting involved. In such cases, NoSQL makes a lot of sense. For example, in social networking sites like Twitter or Facebook, if you look at the kind of data that's processed, right, it's more relevant as content rather than a relational data such as an employee management system or a CRM or more line of business apps. So that's why NoSQL is very well suited in social networking sites, right? And also the ability of the system to scale vigorously for a huge data. So we are talking about millions and millions of data. So it's not possible in those cases for a normal RDBMS to scale out, right? And that's when you need to be looking at NoSQL. Now, the downside of it is a lot of things that are done to the application by the RDBMS have to be now considered and be developed as a part of application by the developers. So your the time to develop the application significantly increases in such cases if you're making a wrong choice, right? So that's a consideration you should have. Now, RDBMS itself is suited more, as I explained, for relational databases, wherever the entities, the domain entities are related and a lot of searching or reporting is required. Now, the downside of it is it cannot scale beyond a limit. But having said that, not all applications need to scale like what Twitter or Facebook needs to also, right? So that is where you need to make a call on what is the priority, whether it's a developer productivity, ease of development, or very high volume of data, or and also look at the type of data you're having, whether it's more relational or just content or document types that you want to store. And based on this, you could go either for a NoSQL DB or an RDBMS like SQL or Oracle. So the answer to it is both are in fact going to exist, and in an application there are going to be scenarios that you use both. For certain kind of data, use NoSQL, and for certain kind of data, use SQL. So a hybrid mode is what preferably many use today. Over to you, Dave.
Thanks, Jyoti. Okay, you have been suggesting of a hybrid kind of a model of mixing up NoSQL databases and RDBMS databases. But if you see in today's world, we have most of the applications running on a structured data in RDBMS like SQL Server, Oracle, etc. So if you want to scale out the RDBMS, what are the options available in today's world?
Okay. So if you look at Oracle, right? Oracle itself has a load balancing capability like Oracle RAC. So this is a very simple way to scale out, right? Oracle RAC, like your web application, like your web services, you could just put a load balancer and your application can be completely abstracted from the way your data is going to scale out. So that's one way out. Now the downside of it is it's extremely expensive and very, very difficult to implement, right? So if I'm not going for this approach, and if I have chosen an RDBMS like SQL, MS SQL or MySQL, what you could do is to adopt sharding, right? Sharding is a design principle, database design principle, where you split the rows of a table to multiple servers and hence balance out the load. So you just, for example, if you take a multi-tenant database, you could split the rows by the tenant to which the data belongs to, right? So, or if you have records pertaining to user, you could have certain user records in one server and certain user records in another server. Now this has to be thought through well from your design and implemented. Unlike the load balancing, which is totally infrastructure in nature, here you need to design for it and develop for it, right? So that's what is sharding about. So the downside is the application needs to do some heavy lifting to bring in sharding, and you also have to very vigorously use some design norms when you go for sharding, like the choice of the primary keys and making sure you do not join tables that could be in a shard, right? So these are some of the principles that needs to be considered while designing as well as implementing your application. So those are the two major ways by which you can scale out when you're using an RDBMS. Over to you, Velan.
Yeah, thanks. Jyoti, you are speaking lots of about how to optimize the code and all those things. But see, earlier the hardware investment is huge in terms for scalability and all those. Today there is a different school of thought. Suppose for a big application which needs something around 200% months or 250% months of the application development, instead of investing that extra 10 to 20% on the performance optimization from the software side, the experts are telling we can leverage the cloud hardware for achieving the scalability, which works so much economical than doing a performance optimization. So do you think, as an expert who has been working in the SaaS and cloud for more than the last 3 years, do you think cloud is a good option for scalability?
Of course, yes, Velan. Cloud is definitely a very good option for scalability, but having said that, performance also needs to be a key consideration. Where cloud helps you is it provides you auto elasticity, right? So the ability to scale up and scale down, and server is no longer a very high cost commodity. You just spin off a server like a thread. Whenever you have a high volume, you just can request for a server, and once you're done with it, you can just bring it down, and that's the power of cloud. So automatic scale out and scale down, both for compute and storage, so at a very lower cost. So that's also key. Once it's available to you, you just can balance out your load as much as possible. You just need to ensure that your application is scalable in a scale out manner. So the moment you ensure that, you could easily go to cloud and use that as a base to scale out to the nth level. And also there are lots of services available in cloud that you could use. For example, you have scalable databases available in cloud, like in Amazon SimpleDB and and the NoSQL database of Azure, you could very easily use that as a mechanism for your data storage. There are caching services available on cloud that you could use to cache your data. I mean, a huge volume of data can be cached. And you also have frameworks available for big data processing like MapReduce available in clouds like Amazon and Azure, which helps you process big data. So all of these ensure scalability to the nth level and also provide you the best of the performance. So that's how cloud can help us.
Yeah, thanks, Jyoti. So to see the different perspective, like Jyoti was speaking on the technology front, okay, on how to do a better development and the deployment, all those things. Okay, let me get in Sabari, senior .NET architect of Aspire Systems. Even though, okay, whether it's investing on the hardware or investing on the performance re-engineering, still the cost is very high because we know a lot of times, okay, the application misses the deadline for the productions and business is getting impacted. So what we can do during the application development life cycle, okay, what the project team, architect, project manager, developers, leads can proactively avoid these kind of performance issues. Maybe somebody, okay, based on his experience in developing high performance application can share his thoughts, okay, how he has done in the past proactively. Sabari?
Yeah, sure, Varun. Anyway. See, as we discussed about the scalability and performance in many factors, okay. See, the performance life cycle actually begins from the start of the software development life cycle, okay. We cannot take it out as a separate life cycle, if I can say, because the performance life cycle starts when from the requirement phase and it goes down to the design phase and then to the development phase and then to the testing phase as well as to the support phase. So it spans around all the phases of SDLC. But basically, what are the key things that we need to actually consider while we do performance, I mean basically to improve the performance of an application and to provide highly performing application is basically while in parallel with the actual application development is, we first define performance objectives basically. So the performance objectives are, response time, like, I mean the responsive of the user request and the throughput actually, if you can see, now what total number of requests or total number of transactions per unit time, okay. So we can define, and then the workload basically. So the workloads are nothing but, the total number of users, concurrent active users, data volumes, transaction volume. So all these things, these are the objectives for an application. So we first define those performance objectives, okay, and then we have to define a performance model, okay. If you can see, performance model are nothing but, actually basically identifying key scenarios and the use cases, okay. So it has a steps to follow, okay. We identify key scenarios where, in the application end, what are the scenarios, okay, it can reach the peak, most critical use cases, and then identifying the workload, I mean total number of users, data volumes, all those things. And then as we define the performance objectives, we need to identify the exact objectives, what is the time, how many throughput, what is the total number of users, total number of requests actually, and then the resource utilization, basically the CPU, memory of this hardware side, okay. And then we actually identify what is the constraint from our end actually, for that application. Constraints are nothing but the execution time that we can allow for that application to handle that request, okay. And then any other resource constraints like the CPU capacity or the hardware capacities, memory capacities, like that. Then we need to identify the exact business processing steps for that key scenarios that we have identified in the step 1. Okay, so that gives us, actually identify what are the steps followed in the scenario, so that we can easily allocate that time for each and every steps. Allocating the budget. Okay, and then we actually constantly evaluate the feasibility and effectiveness of the model that we have defined, and then we have to validate the process and the estimates that we have provided. So once we have come up with a performance model, okay, then we have to define the performance and scalability frame. Okay, it is nothing but identifying the critical area of the application where we can actually through which we can improve the application's performance. Basically, it can be concurrency. That means that the transactions that we use, and then caching. In terms of resource management, and in terms of how we design our objects, like taking of coupling and cohesion, all these things. So once we define that scalability frame, then we actually start testing it and measuring against our performance objectives that we have set. Okay, so so during this process, we actually make use of a lot of tools available to do stress tests, load tests. Okay, and then at the same time we also optimize the code. Okay, while doing so, we need to follow some of the best practices in the industry, or in any of the languages that we have. Okay, so if you can see, we need to broadly categorize the performance and scalability considerations, like when you write, proactively develop the application. So if it starts from the architecture and design. Basically, how you set up the communication. What are all the best practices you have to follow for communicating between different components? What kind of caching? What data we need to cache? Okay, so what kind of best algorithm we are going to use for this business case? Okay, what is the best deployment architecture? Because we have been, Jyoti was talking about scalability in terms of how we scale out and how we scale up. Okay, so what kind of deployment architecture we are going to make use of it? So those things as a checklist we should have during this performance complete life cycle itself. Okay, and then if it is a web application, okay, so you need to consider few of the specific, specific to the web. So basically, how the page, page and web server processing, okay, and then what kind of data access considerations that we are having, okay, and we also need to take care of the client-side optimization, because the web is basically where we have a 10 client where browser needs to load a lot of amount of data. So it could be the page where we have a lot of controls, a lot of scripts and all. So we need to see how we can actually optimize the client side also. So if we can go about the managed code, basically if it's .NET or Java kind of thing, so we need to see how basic string manipulation, what kind of data structure we need to use for the specific data that we are going to handle. Okay, so are we going to use dynamic operations like late binding, reflection, all those things. Okay, so from the database end also we need to very much consciously use some of the best practices. Okay, in terms of what kind of joints we are going to make. Do we, from the design of table itself, okay, do we have proper indexes, okay, and also we need to make use of the execution plans. If you take SQL Server, okay, we have execution plans, so through which we can identify how much time or what is the resource and how the actual query is being actually executed. So we will get an idea, and so we can easily optimize the code. And there is another option that what Jyoti was talking about, the sharding, that is database partitioning. So those things we need to keep it in our hand when we actually do this. So these things will help us. The next part is the capacity planning. So when we have all these things and we do optimize the code, have the tools, have the best practices, and start optimizing. Okay, this will give us where to we can easily manage our capacity of the hardware or deployment side. Okay. So in parallel, okay, if you can see, there are the business services or functional requirements will be coming in parallel. Okay, there are application developers who actually write fixes or enhance the application. Okay, this also will be done parallelly. So during that phase also, we will actually we have to monitor the performance during different tools. Okay, and then actually this each and every time when there is a change in the application end, it has to go through the complete life cycle. Like defining the use cases and defining the performance objectives, and then use the frame for that enhancement and measure and test. And then if you can see, when each and every time we do this as a cycle and deploy it and do that. So this is all about performance life cycle. Yeah.
Yeah. Thanks. Sabri, for an elaborate explanation how proactively to develop a high performance application. And one of the main points when it comes to the performance is the capacity planning. Maybe I should rope in Sheikh, because he has worked for large business enterprises which have been growing aggressively year on year and quarter on quarter. So when the business is growing very aggressively every month, every quarter, so how difficult is to do a capacity planning, and how important to do it, and what are the different methodologies we have in doing this capacity planning? Maybe I request Sheikh to share his experience and thoughts on capacity planning.
Okay, sure, Venan. So as we talked through the performance and scalability and capacity, so how do we measure what we need to build for that performance and scalability, right? So we need to consider the current capacity. So as Jyoti and Sabri and everyone was saying, each application has its own unique way of measuring. Like for example, social networking sites, it's all content, so you need to measure how many users are going to use the contents and what are the operations they're going to do, right? So there are three main steps that we need to go through, and I think these three steps come across in the methodologies that we need to do for capacity planning. One is to just analyze the current capacity, right? It's easier to measure what we do today. I mean, it could be operations, it could be logging, it could be metering, anything that we do today, measure what the current capacity is. Track the utilization, and then look at the peaks of the workload that's happening on that application, on the system or application. Right? Then plan for the future, right? Talk to business, talk to people around, talk to the future enhancements, future strategic initiatives. See what we are doing as a company. Are we going acquiring people, or is there a mandate, or is there a any compliance that we need to do that's going to explode our usage? So plan for the future, forecast the workload, depending on what is the scalability and what is the future direction of the company. Then comes, once we have the current capacity, then see current capacity, what we are using from the hardware, cloud, infrastructure perspective. Take that and forecast the future capacity, right? Determine the future capacity of what we should get and what we should do to determine the future capacity. And then once we have the capacity, we need to also consider the service levels, like SLAs, right? Service level agreements of what is business, or what is the consumer, or what's the customer expecting us to do from the performance perspective, and how scalable they should be. One of the things I know Aspire did a good job. I think Jyoti was here for iPay Systems, and Jack Henry was about doing the monitoring, metering, and we also got great help from Aspire Systems about how we can, how to forecast and get our infrastructure for a service bus, and Jack Henry service bus that we are doing. Now these are the three steps that we need to do for capacity planning. I know we are running out of time. I just want to quickly touch base on the two methodologies that I know of that we can use. One is the transaction cost analysis and the predictive analysis. Transaction cost analysis, it calculates the cost of the most important user operations in terms of limiting the resource for that, right? Then the predictive analysis, which is forecasting the future resource utilization of the application. This is purely based on the performance. So those are the two methodologies, and these are the high-level steps that we need to follow if we have to do capacity planning. I think that's all I have for capacity planning, Velan. Does that answer your question?
Yeah, thanks, Sheikh, for your insights on the capacity planning. So now we can take, we have another 4 minutes to go. Okay, we will quickly touch upon the questions that was thrown out by the participants. One of the question is, what are the key considerations for building the high-performance mobile apps? So maybe I can request Sabari to respond to this question.
Yeah, Varun, sure. Actually, yeah. But when you say mobile applications performance, okay, something comes into mind is first thing is since mobile is very thin, where the application is very thin, and it majorly depends on the services from the other end. Okay, so what kind of communication mechanism that we are going to use is what the first thing that comes to my mind. So one is there are two ways we can handle RUNAs, make use of SOAP and XML, or REST or JSON. So basically, SOAP, XML, SOAP is the communication protocol, and XML is the message format. Okay, and the other part is REST and JSON. So I feel SOAP and XML is very if you can is very much big and huge enough for a mobile application, because it has large amount of time. The XML is very big in terms of SOAP. Okay, so the serialization deserialization time will be very huge. So in mobile related application, it is better to make use of choose REST and JSON based communication mechanism. Then the next one is the caching mechanism, that what kind of caching mechanism that can be very much useful for mobile application. Okay, one of the things, like if you take HTML5, okay, we have app cache has been enabled in HTML5. Okay, it is something like how we cache from your normal application, web application and all, how we can cache. So the app cache in HTML5 allows you to cache applications data locally in the browser in itself, so you can manage easily. So that is one of the options you can use when you go for mobile. And in terms of deployment, another thing comes as a mobile CDN. That is, CDN is nothing but content delivery network. Okay, so content delivery network is basically delivering that users request content from remote places. So mobile CDN is a new thing comes, we can make use in terms of deployment. So other than that, of course, we need to still make use of the same whichever language we are doing. We need to make use of the best practices on that, so and write the code. So I think these are the major things that we can consider for mobile applications performance.
Yeah, thanks, Sabari. Okay, I hope it was an exciting session, and everyone who attended it, okay, has got some value about, okay, how to develop a high performance application. And I'd like to thank and appreciate the panel members, Rusiru, Sheikh, Jyoti and Sabari, for taking time off and answering our questions. So it's back to Archana, the host.
Thank you, Valen and other speakers, and thank you, participants. We really appreciate your participation. The PPT and the other webinar materials will be emailed to you in another 2 to 3 business days. Once again, thank you all for your participation. We are signing off.